Okay, so the National Radiodynamic Zone. I'll talk briefly what it is. I can use the cursor here. Is that how it works? Okay, perfect. Now you're good. So the Creek Observatory, it's located in California. So if you ever happen to be in rural California, somewhere out there, just please let us know and come visit us. It's a really cool place, and there's so many exciting things happening. So that's a Google Maps basically satellite image of the site, and then if you zoom in, you can actually see the dishes, which is kind of cool. Okay, so what are the takeaway messages for the National Radiodynamic Zone? So the electromagnetic spectrum is a finite resource. And what I mean by that is as we introduce more and more communication protocols, we're just filling up that the spectrum. And so at some point, we will start to get into a problem where we don't have enough spectrum to actually do the things that we need to do. And here I'm tackling the problem from a radio astronomy perspective. So radio astronomers are users of the spectrum. They are, albeit they are passive users of the spectrum. And so this trend of increasing the load on the electromagnetic spectrum will only accelerate. And we need to find ways in order for us to share the spectrum. And one of those ways is what we call the National Radiodynamic Zone, which I'll talk about in a bit. Okay, so what are the goals? So the goals for this program, it's a National Science Foundation. So the NSF has realized that this is a problem, or it will become a major problem in the next few years. And so there's a lot of effort, also as you heard in the morning's keynote presentation. So there are three basic goals, or three main goals for the NRDZ project. The first one is an RF baseline survey, or RFBS. I don't like that naming, but that's another topic. So we have deployed antennas and USRPs on site that measure the baseline noise of the observatory, and we can use that for later on for thresholding. We're also going to provide this RF open datasets, and we do have RFI visualization tools. For the spectrum sharing itself, so we follow some sort of a model that we use that is already out there, such as the Citizens Broadband Radio Sharing and the AFC, or the Automatic Frequency Coordination. So it's basically a way to let active transmitters and active receivers or passive receivers know when the electromagnetic spectrum is being utilized. And for the forward activities, I guess we're prototyping this concept, and we also extend to getting satellites and doing that for satellites too. So okay, so what is a National Radiodynamic Zone? So we are now defining it basically. So we're leading the effort in defining what that would mean. But so kind of to make a distinction between a radio quiet zone is a place geographically on Earth that active transmitters are not allowed to transmit, basically. So that's a radio quiet zone. A radiodynamic zone is a geographical location on Earth where transmitters can share the spectrum. And this is a nice sort of description of how it is. So if anyone has questions or ideas or any ways that we can collaborate, please let me know. I'll be here for the rest of this afternoon and tomorrow. Thank you.